everyone, my name is SYAHIERA and I will be presenting chapter 5 for question 1. The question is, in how many ways can a photographer at a wedding arrange 8 people in a row, including the bride and the groom? If A, the bride must be next to the groom, B, the bride is not next to the groom, and C, the bride is positioned somewhere to the left of the groom. Okay, we'll go right into part A where the bride must be next to the groom. First, we do the calculation for 7 factorial, then we will get 5040. Now, for each of those 5040, there are only 2 possible arrangements. So, 2 factorial multiply by 5040. So, the answer will be 10,080 for part A. Next is part B, where the bride is not next to the groom. First, we calculate the total values, which is at factorial, and we will get 40,320. Then minus the value that we calculated from the previous statement, because these are the numbers of the bride is together with the groom. So 40,320 minus 10,080 equal to 30,240. So that will be the answer for part B. The last part is part C, where the bride is positioned somewhere to the left of the groom. First, we calculate the total value, which is x factorial. Again, we have to calculate the total values again, and then we will get 40,320. And since there's only 2 options regarding of the position of the bride in regards of the groom, either to the left or to the right, you need to divide it by 2. So the answer for part C will be 20,160. That is all for question 1. We'll be moving on to the next presenter.
My name is HAKIM bin MAHADI and I will present question 2 for the chapter 5. So for the question 2, suppose that a password for a computer system must have at least 8 but no more than 12 characters, where each character in the password is a lowercase English letter, an uppercase English letter, a digit, or one of the 6 special characters. So for the question A, how many different passwords are available for this computer system? So in this case, we have 26 lowercase letter, 26 uppercase letter, 10 digit, and 6 special characters. So we sum all up and we get 68. So we have a total of 68 characters that can be used to make a password. To make a password must have at least 8 characters. But no more than 12 characters. So for 8 characters, we take 68 and power up by 8. And for 9 character password, we take 68 and power up by 9, and so on until 12 character password, and we add all the value and we get 9.9205 power up 21 to the power of 21. For the question B, how many of these passwords contain at least one occurrence of at least one of the 6 special characters? So for this case, in the password contain at least one special characters in this password. So we need to remove all the password that doesn't have any of 6 special characters in it. So how to get it? We take total of the characters is 68 and the total of the 6 special characters is 6. We minus and we get 62. And to get at least one special character, for the 8 character password, 68 to the power of 8 minus 62 to the power of 8, and so on until 12 character password, and we minus total of the password from the question A and question B, and we get 8.4604 to the power of 20. So for the question C, using your answer to part A, determine how long it takes a hacker to try every possible password, assuming that it takes 1 nanosecond for a hacker to check each possible password. So 1 nanosecond is 10 to the power of negative 9, and time taken is 9.9207 to the power of 21. We multiply by 10 to the power of negative 9, and we get 8.4604 to the power of 11 seconds, nanoseconds. It's all from me. Thank you.
I, Muhammad Sakir TANSI, will present Chapter 5, Question 3. The English alphabet contains 21 consonants and 5 vowels. How many string of 6 lowercase letters of the English alphabet contain? First question, A, exactly 1 vowel. B, exactly 2 vowels. C, at least 1 vowel. D, at least 2 vowels. So we move to question A, exactly 1 vowel. Number of ways to choose 1 vowel are 5 ways. There are 6 possible positions to place the chosen vowels. Number of ways to place consonant in the 5 others position, 21 power 5 ways. So the operation are 6 times 5 times 21 power 5. So the answer is 122523030. We move to the question B, exactly 2 vowels. So the first vowel are 5 ways, second vowel is 5 ways, third letter until 6th letter are 21 ways. So use the product rule. We will be use 15 times 5 power 2 times 21 power 4. So the answer will be get 472930375. So there are 72930 strings containing exactly 2 vowels. So we move to question C. See at least 1 vowel from all string of 6 letters. Exclude those that have no vowels. So 26 power 6. We minus with 21 power 6. So we will get the 2, 2, 3, 1, 4, 9, 6, 5 strings. From where we get the 21 without consonant. Thank you. So we move to the last question, at least 2 vowels. Subtract the answer for A from the answer for C. So at least 1 vowel minus exactly 1 vowels. So we get the 2231 49655 minus 122523030. Will we get answer 100626625 strings. Thank you.
Assalamualaikum to Dr. Arif. So my name is Siti YUSLIZAH YUSUF and my metric number is BS21110297. So today I'm going to present my part, which is from chapter 6, question 1. So the question is, suppose that 150 people enter a contest and that different winners are selected at random for first, second and third prizes. What is the probability that Ahmad wins one of these prizes if he is one of the contestants? So my solution is, first I find out the sample size, which is 150, and then for the first prize I let it PF, and then I got the probability is 1 over 150, because there's only one person can win among the 150 people. And then for the second prize I let it be PN, and the probability is 1 over 149. Why is the denominator is 149? Because 150 minus 1, because this one person already win at the first prize. And for the third prize, I let the probability be PT and equal to 1 over 148. Why is the denominator is 148? Because 150 minus 2, because there's 2 prize already taken by the people who enter the contestant. That's why the denominator is 148. So I let PA for Ahmad chances to win the prize. So in order for us to get the PA, we need to add all the probability, which is from PF, PN and PT. So when we add all the probability, we get 0.02012483 to add 2. So we simplify it, we get 0.02 or 1/50. So 1/50 is the probability that Ahmad can win prizes when he joined the contest. I think that's all from me. Thank you.
Assalamualaikum and have a good day. My name is NURUL Izzah Aqilah binti Muhammad HAFIZ and my matric number is BS1110060. And now I will go over question 3 in chapter 6. From this question, we need to highlight that if rolling a 2 or rolling a 4 is 3 times as likely as rolling each of the other 4 numbers on the die, what is the probability of each outcome? First thing first, we need to let the probability of 1, 3, 5 and 6 as x. Then we assume that the probability of 2 and 4 as 3x. Since the probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 and plus probability of 6 is equal to 1, so we rewrite it as x plus 3x plus x plus 3x plus x plus x equal to 10x. Next, we assume that 10x is equal to 1. Then, we solve it and get the answer for x, which is 0.1. After that, we can substitute it into the probability equation as shown, which is equal to 0.1. Finally, since we assume that the probabilities of 2 and 4 are equal to 3x, that means it needs to multiply 0.1 by 3 to get the answer. And the final answer for the probability of each outcome when a biased die is rolled is equal to 0.3. That's all from me. Thank you.
Hello, Doctor. My name is Catching Grace Namsaji, BS21110258. I will be presenting Chapter 6, Question 4. A pair of dice is known. The probability that a 4 appears on the first die is 2/7. And the probability that a 3 appears on the second die is 2/7. Other outcome for each die appears with probability 1/7. What is the probability of 7 appearing as the sum of the numbers when 2 dice are rolled? Now I will present my solution. Assuming both die are the same, let the first die be A and the second die be B. Then we state all the probability for what number will land on both die. As we can see from the table for the first die, all are 1/7 except when the die landed on a 4, which is 2/7. As for the table for second die, all are 1/7 except when it lands on 3, which is 2/7. Now we look to find the combination for the sum of 7. As you can see, how I wrote my formula is the probability of AB equals to A1 B6 plus A2 B5 plus A3 B4 plus A4 B3 plus A5 B2 and plus A6 B1. These are all the probabilities that I found. As you can see, we can assume the combination and just replace the combination with the probability. The answer will be 9/49.
So we move to our Q&A session. So I'll be the first one who will ask the question. So I think my question for chapter 5, question 1. So my question is, why we have to minus the add factorial with the previous statement?
Okay, the previous statement or 10,080 where the bride and groom are next to each other. That means the rest of the total values after we minus is the number of the possibilities where they are next to each other. Because now we are searching for if the bride is not next to the groom, so we just have to minus the total value to the previous statement, which is 40,320 minus with 10,080. Then we get the answer for part B. Do you understand?
Yes, thank you. So I think we move to next question.
Okay, I have a question. Question 3. Why do you consider probabilities second 2 and 4 to be 3x?
Okay,
Thank
I
you.
will answer it. For this question, I consider it as 3x because the question mentioned that a 2 roll or a 4 roll is 3 times of the roll from the every 4 other numbers on the die. Do you understand?
Yes, I understand. Thank you.
Okay.
Okay, and the last question from me. Question 4, chapter 6. Why is they repeat number such as B1 A5 and A5 B1? Thank you.
Okay, so for your question, it's because we want to assume every probable combination, so that will be including repeating numbers. Because the first number could be 1, while the second die could be 6. So even if there's repeating numbers, but it's just it's a different combination again. Since the second die could be 1, and the first die could be 6. So, for example, we use my A1 and B6. You use that example. So we can use the first die as 1, and the second die as 6. And when we do A6 B6 is the other way around. It's still 7, but it's just a different combination. That's do you guys understand that? So therefore, that probability must be counted as well.
Yes, I understand.
I think that's all from us. Thank you.